Good afternoon. Welcome to the class Information Storage Network. In today's class, we'll be discussing about structure and organization of fiber channel data. We have already discussed in the previous video lectures what is fiber channel architecture, the fiber channel protocol stack, different types of ports available in a fiber channel, and so on. So today's class is about structure and organization of fiber channel data. So in a fiber channel network, the data transport happens between two or more ports. So you can compare this data transfer with a conversation that two people have. Alright, so whenever a conversation between two people happens, there are words, sentences, and then there is an entire conversation. So words can be compared with frames, sentences can be compared with sequences, and an entire conversation can be compared with exchange operation. Let's see them one by one. So exchange operation. So exchange operation, it is used for communication between two N ports. Alright, so an exchange operation enables two N ports to identify and manage a set of information units. Right. So in an exchange operation, there are certain, if you recall the fiber channel protocol stack protocol, there are something called as upper layer protocols, and these upper layer protocols have certain protocol specific information. They have certain protocol specific information that must be sent, and this protocol specific information must be sent from one node to another node. So such information is called as information units. Such a set of information is called as information units. Right. The next one is called as a sequence. A sequence means a continuous set of frames sent from one port to another port. So as you say, a sentence is a combination of words. We can say that a sequence is a contiguous set of frames. Next is frames. So frame is a fundamental unit of data transfer. So each frame can contain up to 2112 bytes of payload. Right. So this is how a typical frame looks like. This figure, what you see over here, it is divided into 5 parts: SOF, frame header, data field, CRC, and EOF. SOF refers to the start of the frame. Then there is frame header, which is of 24 bytes. Then there is data field, which is of 2112 bytes. CRC refers to cyclic redundancy check, and EOF refers to end of file. EOF refers to end of file. So start of file and end of file, start of frame, no, not file, so start of frame and end of frame, they are the delimiters. They specify where a frame starts and a frame ends. They specify where a frame starts and frame ends. Then we have the frame header. This frame header is of 24 bytes. So what does this frame header contain? What does this frame header contain? So this frame header contains something called as the source ID, then it contains destination ID and such various types of information. Source ID and destination ID, they are represented with the help of SID and DID. SID and DID, right? Source ID, destination ID. This refers to the ID of the source node, and this is destination node, and this refers to destination node. So this ID is with respect to the node which is sending information, and this ID is for the node which receives information. So these IDs are present inside the frame header. The next one is called as a CRC, cyclic redundancy check. CRC refers to cyclic redundancy check. So cyclic redundancy check is used for error detection. It is used for error detection. It also checks whether the frames are integrated properly or no, which means that it checks whether the frames have been sent and received properly or not. This is what CRC refers to. End of frame, it refers or it indicates that this is the end of the frame. So this is the structure and organization of fiber channel data. The next one, fabric services. The next topic that we're going to discuss is fabric services. So this fiber channel network, it provides different kinds of services irrespective of the manufacturer. There are some common or general services which each of this fiber channel provides. The first one is called as the fabric login server. This is called as fabric login server. Then we have the fabric controller, then the name server and management server. As you can see over here in this diagram, there is a predefined address which is associated with each of these services. Fabric login server has a predefined address, fabric controller has a predefined address, then name server has an address and management server has an address. Then these are the switch ports. So this is the services which a switch provides, and these are the switch ports for input output operations. So what are these fabric services? So whenever a node logs into a fabric, this fabric login server comes into picture. Whenever a node wants to join a particular fabric, it has to first log in into the fabric to perform the input output operation. So if that particular node wants to connect to this particular switch, then the fabric login server comes into picture where this predefined address is assigned to that particular node. Then the next one is called as the name server. The next one is called as the name server. This particular name server is used for responsible for name registration and management of node ports. Name registration and management of node ports. Yeah. What is meant by name registration and management of node ports? Whenever a node logs into a particular fabric, the first thing that happens is that the fabric login server, it assigns a certain address to that particular node. Once that is done, the name server or distributed name server comes into picture. That also has a predefined address. So that node has to register its name to that fabric. So that name registration operation is performed by the name server. The next one is called as the fabric controller. So this fabric controller has a predefined address and it provides services to both node ports and other switches. So all the node ports and switches which are present in the fabric controller provides service to each and every one of the nodes and switches present in that fabric. The next one, management server. So management server, it is used to administer the fabric. Anything related, any other service or the entire fabric management is taken care with the help of the management server. So these were the services which are provided by the fiber channel fabric. The first one, let us repeat it again. The fabric login server, it is located at a predefined address and it is used for the login process of a node to a fabric. So whenever a node logs into a fabric, this server assigns an address to that node. Next, when the node logs into that particular fabric, the name server comes into picture where the node has to register its name to that fabric. Alright. Next, the fabric controller. So the fabric controller provides services to each and every node and also other switches present in that fabric. Second one, the last one is called as the management server. It is used to manage the entire fabric controller. And the next one, switched fabric login types. We already know that if a node has to join a particular fabric, it has to log in. So these are the different types of logins that are available for different types of nodes. We have seen different types of nodes, F port, N port and so on. So whenever these nodes want to join a certain fabric or want to avail certain services from that fabric, These are the different types of logins available. The first type of login is called as F-log-I, which is also called as fabric login, So this login happens between N port to F port. So what happens here? To log on to a fabric, first a node sends an F-log-I frame. So whenever a node logs into a fabric, it sends an F-log-I frame. And along with this, it sends its WWWN and WWPN. It sends two parameters. The first parameter is WWNN, worldwide node name and worldwide node number and worldwide port number. So along with this F-log-I frame, these two parameters are sent. Once these two parameters are sent, the next step is that the switch to which this particular login is sent, it sends an accept request. It tells that the login has been accepted and your request for a particular service has been accepted. So once that is done, then the node port has to register its name. We have seen the services which are provided, the name server. The next is the name server that comes into picture. Once the node logs in, once an accept frame is assigned to the FC address by the switch, the next step is the N port registers itself with a local name server. Every switch has a certain local name present. So the node which logs into the fabric registers itself to that local name server. Alright. Next, once this is done, then any service that is required by that node, it can be availed by that node. Say for example, if an N port wants to log into a certain fabric, then a unique address is assigned. To it. Along with the F-log-I frame, there are two parameters which are sent: worldwide node number and worldwide port number. So using these two parameters, an F-log-I frame is sent to the switch present in the fabric. Once the switch receives these parameters with the F-log-I frame, an accept request is sent to the port. Once that is done, that N port or that port which wants to avail services has to register its name with the local server. Once that is done, then the node can easily avail any of those services which are required by it. This was all about fabric login or F-log-I. The next is port login. So port login happens between two N ports. F-log-I fabric login happens between N port and F port. Port login happens between N port to N port. So this is the sender and this will be the receiver, or one N port will be the sender and the other N port will be the receiver. So data exchange happening between N port to N port is called as port login or P-log-I. The next one is called as the process login. What is the process login tell? The process login happens between two N ports and to share information about the upper layer protocol in use. If you recall the fiber channel protocol stack, there are certain upper layer protocols present. In the FC4 layer, there are certain upper layer protocols which are in use. So to share information regarding these upper layer protocols, it is called as process login. If an N port wants to share information about this SCSI initiator, then process login is used. So this upper layer protocol information is exchanged between one N port and another N port. So these are the different types of logins available for a fiber channel. So the next topic that we're going to discuss is fabric management, and that is called as zoning. It is called as zoning. So this is the fiber channel storage area network. So this is a storage systems. These are all the nodes which are connected to this fiber channel storage area network. As you can see there, this blue color oval, this is zone 1 and zone 2. So if you want to logically divide, all the nodes or all the nodes present in the fiber channel SAN into logical divisions, then each of this division is called as a zone. So zone 1 will contain a set of nodes, zone 2 also will contain a set of nodes. So this logical division of nodes present in a fiber channel SAN is called as zoning. So what are the advantages of zoning? So this is how zoning takes place. There are zone sets, there is zone, and there are these members, So a zone can consist of many members, and a set of zones is called as a zone set. So these members, these down green boxes what you see, these are all the nodes which are present in the fiber channel SAN. So a group of all these members can be divided into number of zones. So one zone can have multiple members, and one member can belong to more than one zone. And a group of these zones is called as a zone set.